let's take a journey into a place you visit every single day, but have probably never actually seen: the inside of your computer. We're going to go way beyond the screen to really understand the magic that's happening with every single click. So let's get into it. I mean, have you ever really stopped to think about it? Every time you tap an icon or type a sentence, there's this incredibly complex dance of events happening in a flash. But how does it all work? What's actually going on under the hood? Well, we're going to answer that, and we're starting with the most basic thing of all: the language your computer speaks. So before we can meet the hardware, we have to understand its language. And you might be surprised to learn that every single thing a computer does, from playing the most complex video game to sending a simple hello, is all built on a language that only has 2 symbols. For us humans, everything revolves around 10 digits, right? 0 through 9. It's just how we're wired to think. But computers, they operate on something much, much simpler called base 2, or what we call binary. They only use 2 symbols, a 0 and a 1. And believe it or not, that incredible simplicity is what makes them so powerful. Okay, and here's the part where it all really clicks. Binary isn't just some abstract math concept. It's physically real. A computer is essentially just a box filled with billions, literally billions of microscopic switches. A 1 simply means a switch is on and electricity is flowing. A 0 means that switch is off. That's it. Every photo, every song, every single command is just a massive, unbelievably intricate pattern of these simple on and off states. All right, so we've got the language down: 1s and 0s, on and off. Now let's meet the physical parts that are actually doing the talking. This is the hardware, the actual body of the machine. First up, you've got the undisputed king of the components, the central processing unit, or CPU. This is the computer's brain. It is where all the thinking, all the calculating, all the heavy lifting happens. And inside this one little chip are billions of those tiny switches we just talked about, all flipping on and off at incredible speeds just to carry out your commands. Think about that for a second. Billions of switches firing in perfect sequence just to open a single file. It's mind-boggling. Of course, a brain needs memory to work, and a computer is no different. It has 2 main types that are always working together. First, you've got RAM, which is like the computer's short-term memory. It's the workspace that holds all the data for whatever you're doing right now. Then you have your storage drive. That's the long-term memory, kind of like a filing cabinet that holds all your files and software permanently, even when the power's off. Now, that long-term memory has changed dramatically. For decades, we all used hard disk drives, or HDDs. You can picture them as tiny record players with a physical arm reading data off of a spinning metal platter. All that movement creates a delay, but modern solid-state drives, or SSDs, have no moving parts at all. They use flash memory, which makes getting your files almost instantaneous. Honestly, this is the single biggest reason why a new computer boots up in seconds, instead of what felt like an eternity. So we have the physical body, the brain, the memory, the storage. But what sparks it all to life? What gives it a consciousness that actually lets us interact with it? Well, that's the job of the operating system. The operating system, or OS, things like Windows, Mac OS, or Android, is the master controller. It's the critical piece of software that translates between you, your applications, and all that hardware. The best analogy is really a conductor of an orchestra, making sure every single component is working together in perfect harmony. So what is this conductor actually doing? Well, for one, it creates the user interface, the whole world of icons and windows that we see and click on. But behind the scenes, it's a master multitasker. It's constantly deciding which app gets to use the CPU and how much memory each one is allowed to have. And on top of all that, it's also the guardian, keeping an eye on the system's overall health and security. Okay, so thanks to the OS, our computer is alive and we can use it. But a computer all by itself is really just a powerful box. Its true potential is only unleashed when it connects to the rest of the world. So how does that even happen? Let's just quickly break down what happens in the split second after you hit enter on a web address. First, your browser asks something called the DNS. Think of it as the internet's phone book, to look up the site's numerical IP address. Second, your router uses that address to send your request out across the internet. Third, a powerful computer somewhere else, called a server, gets your request. And finally, that server grabs all the website's data and sends it flying right back to your screen. It is an amazing relay race that happens in the blink of an eye. Okay, so our machine is on, it's running, and it's connected to this massive global network. But that connection is a two-way street. And just like any open door, it means we need some protection. We need a digital shield. A key piece of that shield is the firewall. The best way to think about it is like a bouncer at a club. It stands at the door to your internet connection and it checks the ID of all the data trying to get in or out. If anything looks suspicious or if it's not on the guest list, it gets blocked. It's a simple idea, but it's your first line of defense against all sorts of threats.
This brings us to a really simple but incredibly powerful security checklist. Number 1, make sure your firewall is on. Number 2, always keep your software updated. Why? Because hackers are constantly looking for security holes, and those updates are what developers release to patch them up. And third, please use strong and unique passwords for your accounts. These 3 simple habits are the absolute foundation of staying safe online.
And there you have it. We started with the absolute simplest concept you can imagine, a single on-off switch. And we built our way all the way up, layer by layer. From the hardware that processes billions of those switches, to the OS that brings it to life, the network that connects it, and the shield that protects it. Each layer depends on the others to create this seamless experience that, let's be honest, we all take for granted. Once you really understand the basic building blocks of today's tech, it's impossible not to wonder about tomorrow. As all of these components get smaller, faster, and way smarter, what new possibilities are they going to unlock? What will the next evolution of computing even look like? That's something to think about. Thanks for digging into this with us.